One-to-one functions and the horizontal line test. All right. So we've talked about functions before. When we talked about functions, we said that every x value has to have at most one y value. And it needed to, visually, it needed to pass the vertical line test in order to be a function. So the vertical line test was like, hey, if you have a graph, we know that that graph represents a function if you can draw any vertical line and you only ever hit the graph once at any given spot. So any place I put this vertical line, notice I'm only touching that graph once. And so we can say that this guy right here is a function because it only hits once anywhere. On the other hand, if I were to draw, let's say, a circle, it's not going to even matter where I put this vertical line. There's many places where I can put this vertical line and have issues. Look, it hits here and it hits here, so it hits twice. This guy hits twice as well. So you fail the vertical line test if you draw a vertical line and you hit the function twice. And if you fail the vertical line test, you can say, well, this graph does not represent a function. Not a function. Now, if we go back to our previous video that we did, oops, which I was already scrolled down on, and we look at these inverses that we drew, think about whether or not the inverse represents a function, a graph of a function. So if I'm just looking, ignoring the lines that were originally there, ignoring the original function, but just looking at the red ones I've drawn, this guy right here, well, this represents a function. This inverse is a function. I'll make a note right here. Inverse is a function. Passes the horizontal or the vertical line test. And if we look here, this little red graph here, that would pass the vertical line test. So the inverse of this graph is a function. But when we look at this one over here, if you were to draw a vertical line up and down, as vertical lines are, you'll see that these vertical lines are going to hit the function, or not the function, the graph in two places, meaning that this inverse that we drew is not a function. It is the graph of the inverse of this function. This guy right here is a function, but his inverse is not a function. And the reason that this is an important conversation is that functions are obviously really nice things to work with. They take in an x value, they do something to it, they spit out one y value and one y value only. And so we really like when things are functions versus when they are not functions. And it makes us interested in what types of functions have inverses that are also functions. And that brings us to one-to-one functions. So if a function is one-to-one, we say it's one-to-one if its inverse, no, that's not how I wanted to say that. A function is one-to-one if every y value has at most one x value. And if a function is one-to-one, then its inverse is also a function. So instead of trying to pass the vertical line test, which just tells us that something is a function, we instead have a horizontal line test that tells us if a function is one-to-one. Again, if that function is one-to-one, then we know that its inverse is also a function. So if I draw a picture right here, Passing the horizontal line test means I can draw any horizontal line and only touch the function once. So look, I'm only touching the function once, only touching the function once, only touching the function once, only touching the function once. This guy passes the horizontal line test. And therefore, this is a one-to-one function. That means that the inverse of this graph will also be a function. On the other hand, our friend the parabola, this one is not one-to-one. This is not one-to-one. So if I draw a horizontal line here, you're going to see it hits in two different places. This is not one-to-one. And that means that the inverse of this function is not itself a function. So it fails the horizontal line test. That means that this function is not one-to-one, which means that its inverse is not a function. Okay. Once again, the vertical line test tells us whether something is or is not a function. Okay. And a horizontal line test tells us whether a function, so you're already assuming it's a function, right? Make sure it's already a function, tells us whether a function has an inverse that is also a function. And if a function is one-to-one and the function's inverse is also a function, we call the inverse function. So a function has an inverse if it's one-to-one, function is one-to-one if it passes the horizontal line test. The notation for this, for inverse functions. If your original function is f of x, then the inverse function of f of x is denoted this way, with a little -1 here. So it's like a superscript -1, sort of in the same location you would put like a square. Now I want to make a note here of a few things. So first of all, the way you would say this out loud if you saw this would be f inverse of x, f inverse of x. And then the other thing I want to note is that this little -1 up here is not an exponent. It's in the same location as an exponent, but it itself is not an exponent. So this is not f being raised to the -1 power. This is just the notation we use to denote that this function is the inverse of the function f. Okay, so not an exponent, f is not being raised to the -1 power. The -1 denotes this is f's inverse function. And I make that note because if you have x to the -1, this is 1 over x. So it's a little bit weird that this right here doesn't mean 1 over f of x, right? It's a little bit strange because it almost feels like it should, based on the fact that negative exponents typically do that, but it doesn't. So let's go ahead and look at a few graphs and determine whether or not these represent one-to-one functions. So we're going to use the horizontal line test to see if these are one-to-one functions or not. So right here, you can see this guy's going to hit in multiple places, right? All you have to do is find one place where it fails for it to not be one-to-one. So this guy right here is not one-to-one. Fails the vertical line test. This guy here, any line we draw is going to only hit the graph once. So this right here is a one-to-one function. Over here, get right down here, I am hitting the graph twice, so I am not a one-to-one function. Down here, all right, there's a few places we have to be careful. So we're good, we're good, we're good. We have to question right here and ask, is there an issue happening here? And the answer is no. So we don't hit the graph twice actually, because there's only one point here. There's one point and this is an open circle. So there's no point at the open circle. So these guys right here, they this is fine. This is a one-to-one function. Over here, for this guy here, right up at the top, we're going to see that we hit 2 points. This horizontal line does. So this right here, not one-to-one. And then over here, only hit 1 point. Oh, if we get down here, it looks like we're hitting 3 different points. So this guy is also not one-to-one. So to summarize here, we know a function is a function if it passes the vertical line test. And what that means for something to be a function, and maybe I should have said this at the beginning, is that every x value has at most one y value, which means that the point 2, 5 and 2, 7 couldn't be on the same graph, right? It prohibits there being 2 different points with the same x value and different y values. Because if you think of the way that functions work, that makes sense. F of x is equal to x plus 2. If I put in an x value, like the x value 2, I'm going to get out 4. And there's no way for me to get anything other than 4 out of it. If I put 2 in here, it puts 2 here. We add 2 to 2, we get 4. There's no way for a function that operates in this way to put 2 in and get a different answer other than 4. So functions require that you can't have 2 different points where the same x value has different y values. Down here, in order to make sure that the function has an inverse that is also a function, we make sure additionally, on top of the fact that 2 points can't have the same x value, we make sure that no 2 points have the same y value, because think about what happens when we invert those points. A one-to-one function says that the point 0, 5 and 2, 5 can't be on the same graph. It says you can't have 2 points that have the same y value. Can't be on the same graph. You can't have 2 different points that have the same y value, because when you invert these points, the inverted form of these become 5, 0 and 5, 2. And if we have the points 5, 0 and 5, 2 on a graph, then those aren't going to be, that's not going to be a function that fails the vertical line test. So that's what one-to-one is doing. It's ensuring that when we invert the points, we don't end up with something that would fail the vertical line test. And so that's, I think, all I have to say for this section here. That's the vertical line test. That's everything you need to know about it. So in the next section, we're going to talk about some fun facts about inverses, and then we're going to learn to take inverses, and it's going to be a great time. I'll see you in the next video. Bye.